To do basic decimal short division, you really just need to be able to complete one of these division algorithms successfully. Now, you'll notice that this number here has a decimal in it. The only trick that you need to know is to keep your numbers lined up in columns and to also keep your decimals lined up. And if you do that, this is really no harder than doing 635 divided by 5. And the trick is that the decimal will just automatically land in the right place and you'll actually have 63.5 divided by 5. So let's have a look. 6 divided by 5 is 1, remainder 1. 13 divided by 5 gives us 2, remainder 3. And we just act as though that decimal's not there and go straight across, pretending that it's 635. Now we have 35 divided by 5 is 7, and the answer gives us 12.7. Now, as long as you've kept things lined up in the right columns and the decimal lined up, the answer should be right. But it never hurts to think, does that make sense? 12 and a bit times 5, would that be around about 63? And that makes sense because 12 fives are 60, so the answer seems right, and you can tell just as a basic check there that you haven't done anything wrong. Let's have a go at this one. Lining the decimal up straight away helps me get started, and then I can treat these as though there is no decimal. 0 divided by 4 doesn't go, so I put a 0 as a placeholder there. 0 divided by 4 still doesn't go. 8 divided by 4 is 2. 3 divided by 4, well, that doesn't go, so I need to put the 0 in again as a placeholder, but I haven't actually used the 3 yet, have I? So the trick is you need to extend the 3 and say it comes across here with the 32, so that I have 32 divided by 4, which is 8. Some people prefer to say, well, I haven't used the 3, so it's basically a leftover, and they put the 3 in there like that. It's still 32 either way. So those two examples were pretty straightforward. When we got to the end, the last number went exactly, didn't it? Let's have a look at what to do when it doesn't go exactly. Now, this question down here doesn't actually look like a decimal short division problem because 418 is a whole number, isn't it? So it doesn't look like a decimal thing. But let's see what happens when we go to do it. 4 divided by 3 is 1, remainder 1. 11 divided by 3 is 3, remainder 2. And 28 divided by 3, well, 3 nines are 27, so it goes 9 times with 1 left over. Now, remember you used to write it like this, remainder 1, okay? But there's a couple of ways we can go here. You can either use it as a fraction and say, well, if we had 418 pizzas, say, and 3 very hungry, well, they'd be giants, wouldn't they? Then if we gave the giants 139 pizzas each, and there was 1 remaining pizza, that remainder 1 is the last pizza, what do you think 3 hungry giants would do? Yes, they would probably divide it up into thirds, wouldn't they? So that shows us that we get this, okay? Now, we can also do this as a decimal, and here's the trick. If you have this line to extend along a bit, and you say, well, we've got exactly 418 here, and not a tiny bit more, we have 418.0, and you can put as many zeros there as you like, okay? Now, how many should we put? Well, for the moment, let's just put 3 and see what happens. Now, at this point, when I have my 1 left over, I've actually got some places to hold my leftovers, don't I? And the decimal needs to go up there to keep it in line. So when I do 28 divided by 3 and I get 9 remainder 1, I can put my 1 down here, okay? Now I say 10 divided by 3 is 3 remainder 1. 10 divided by 3 is 3 remainder 1. And 10 divided by 3 is just going to keep on being 3 remainder 1. So no matter how many zeros I put here, I'm going to have a line of 3s that go on and on forever, aren't I? And that reminds us that 0.333, or some people will prefer to write it, or already know that it can be written as 0.3 repeater, is the same thing as a third. But this trick is one that you can use for all kinds of decimal problems.